Okay, guys, so let's start off with a new concept in this chapter called as chemical bonding. So suppose if two atoms are nearby to each other, atom A and atom B. Okay, so these are the centers of the two atoms or the nucleus. Then suppose these are the two electrons. Then we can have repulsive forces between the neighboring or other between the electrons of the two atoms, as well as we can have attractive forces, repulsive forces between the positive charge as well. So these are all the type of forces that can happen from between the electrons and the protons of the two atoms. So if we draw the potential energy graph with the distance of their approach, we would get a graph something like this. At this point, we get that the forces, attractive forces equals the repulsive forces. At this point, we have attractive forces are lesser than repulsive forces. Up till this point, at this point, attractive forces equals to repulsive forces, and after this point, attractive forces dominate the repulsive forces. Okay, so this is the point. So this length is called as bond length. So we can say that according to quantum theory, when two atoms approach each other, there will be the force of attraction as well as force of repulsion between bonded atoms, and as the minimum distance, or rather at the minimum distance where these forces become equal, is called bond formation condition or equilibrium condition, and the minimum distance between the atoms is named as bond length, and the atom of elements are stabilized by releasing their energy through bond formation. So next we can write that bond formation is always exothermic process, energy is released, and bond breaking process is always endothermic. You have to provide some energy for the atoms to separate them apart. Okay, next we can say that noble gases, which is helium, neon, etc., are stable in their atomic form, hence they do not have their molecular, they do not have their corresponding molecules. So we can write that noble gases, helium, neon, etc., are stable in their atomic form, hence they do not have their corresponding molecules. Okay, next let us see what a chemical bond is. So chemical bond is a type of force of attraction that exists between bonded atoms after bond formation, and its bond dissociation energy is greater than 42 kilojoule per mole. So bond dissociation energy of a chemical bond is greater than 42 kilojoule per mole, and if the bond dissociation energy is less than 42 kilojoule per mole, then it is called as chemical force, not a chemical bond. If it is greater than 42 kilojoule per mole, then it is a chemical bond. Okay, next let us see the classification of chemical bond. Classification of chemical bond. So we have two types of chemical bonds: strong chemical bond and weak chemical bond, rather weak chemical force. So strong chemical bond has bond energy greater than 42 kilojoule per mole. Bond energy is greater than 42 kilojoule per mole. And for weak chemical force, bond energy is, rather we can say that the bond dissociation energy is less than 42 kilojoule per mole. Okay, so strong chemical bond can then be categorized into three categories. First is covalent bond, then we have metallic bond, then finally we have ionic bond. Okay, so this exists between atoms or ions, and weak chemical force again can be classified into two categories. One is hydrogen bond and another is van der Waals force of attraction, and then van der Waals forces. Okay, so this actually exists between molecules. Okay, so covalent bond is generally seen to exist between non-metal, between atoms or ions of non-metal and non-metal. Ionic bond is generally seen to occur between metal and a non-metal, rather between atoms of metal and non-metal. And metallic bond is seen to occur between two metal atoms or ions. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on chemical bonding. So till then, good luck and goodbye.